Hello and welcome to another episode of the Space Weather This Week. In this weekly bulletin, we bring you the latest conditions in space weather, including the solar and interplanetary events. If you want to know, understand their implications, do not miss our news on space weather, the Space Weather This Week. Let us begin our news with the conditions of the Sun. The Sun, which is the source of all space weather events. The magnetic filaments on the surface of the Sun can be the site for solar flares. Magnetic filaments are the solar filaments are dark lines or curves that sometimes appear in pictures of the Sun. Filaments are actually huge arcs of plasma in the Sun's atmosphere. They look dark because they are not as hot as the Sun's surface behind them. These filaments are held in place by powerful magnetic fields in the Sun's atmosphere. They usually appear above sunspots, which are magnetically disturbed regions on the Sun's surface. Filaments can last for several days, or sometimes up to months. Although magnetic filaments are most common around the peak of the sunspot cycle, when the Sun's magnetic field is very active, it can also be seen during other phases of the solar activity. Filaments are actually the same feature as another solar phenomenon, prominences. Prominences stick out from the edge of the Sun and look bright against the dark background of space. However, prominences and filaments are really the same thing, arcs of plasma in the Sun's atmosphere held up by magnetic fields, just viewed from a different angle. Such filaments have been observed on the Sun on the 9th of May. The longest of these filaments stretches more than 400,000 kilometers from end to end, about the same as the distance from Earth to the Moon. Magnetic filaments are unstable structures. When they explode, debris can fall to the surface of the Sun, triggering a type of solar flare known as a Hyder flare. Filament eruptions are also very good at hurling CMES into space. One pair of the sunspots on the Sun did flare on May the 11th at 13:55 UT, and another near the midnight of 12th. These flares happened when one pair of the sunspots coalesced through reconnection. An X-1.5 class flare explosion happened. Radiation from the flare ionized the top of Earth's atmosphere, causing a shortwave radio blackout around the Atlantic Ocean. The first sunquake of solar cycle 25 rippled away from this flare of X-1.5 class solar flare of May the 11th, 2022. 26 years ago, researchers discovered seismic activity on the Sun. These are named as the sunquakes, much like earthquakes except incredibly more powerful. A typical sunquake contains 40,000 times the energy released in any massive earthquake. These solar seismic waves travel through the Sun's interior and probably recombine on the opposite side of the Sun to create a faint duplicate of the original ripple pattern. The flare might also have hurled a complicated CME. So far this week, the Sun has flared more than 20 times and hurled many CMES into space. Not one of them headed straight to the Earth. The sources of these two CMES are far-side sunspots, one located just behind the Sun's eastern limb and another just behind the Sun's western limb. A wave of relatively high-density solar wind passed over Earth's magnetosphere on Friday, the 13th. The solar activities shooted up solar X-ray flux on 11th and 12th, while the proton flux appreciated on 13th of May, in this week. So these are the space weather conditions we experienced last week. Thank you very much for being with us. The presentation has been made by spaceweather.tech. Please like and subscribe to us for receiving space with the news every week.